Welcome to this session on water stewardship and renewable energy at scale. My name is Will Hughes, and I'm the global lead for water sustainability at AWS. And I'll be joined later by my colleague Paul Reed, the GM for Clean Energy Sustainability. We're really excited to be here tonight talking to you about three of our key sustainability commitments at AWS and how we're scaling progress towards those goals. I'm going to give an overview of the new goal that we launched this week around water stewardship. I'll give details on how we're going to meet that goal and how we're using AWS services to scale impact within that goal. And then Paul will be talking about the similar progress towards the renewable energy goals. Before I start, when I think about sustainability, I think about a couple things. I think about fighting climate change, and I also think about protecting and restoring the places and ecosystems that we love and that provide clean water. Places like this lake high up in the mountains in the Cascade Mountains in Washington, one of my favorite places to go backpacking and hiking. From the newspaper headlines we see every day and from the weather when we walk out the door, we know that climate change is having an impact on these ecosystems. And there's constant reminders of the urgent challenge that climate change poses. Paul's going to focus in on the impacts of climate change and two of the key sustainability goals that we're implementing to fight climate change. One is the Climate Pledge, which we launched in 2019 to achieve net zero carbon emissions by 2040. And the other is our 100% renewable energy goal, which Paul will be talking about. But first, I'm going to focus in on the water side of the equation. We experience a lot of the impacts of climate change through the water cycle, so they're closely related. And so I'm going to talk about some of those challenges around water and how AWS is implementing our water sustainability program to combat them. So what are some of those challenges? Well, today we face a few challenges around water quantity, water quality, and water access. Today, 10% of the world's population doesn't have access to clean water. And we're expecting that half the world's population is going to live in regions impacted by water scarcity by 2025. And the bad news is climate change makes a lot of those problems worse. As the atmosphere gets warmer, it can hold more water. And so we see more infrequent rainfall, but when it does happen, it tends to come in greater intensity. So we see greater floods and also greater droughts. And the ecosystems and the infrastructure that we've built to manage water aren't equipped to handle those extremes. Water is central to public health, it's central to a functioning economy, and it's central to vibrant ecosystems. So how does water interact with AWS's operations? At the broadest level, AWS uses water for cooling in many of our data centers. And in fact, it's really the right thing to do. When we use water for cooling, we're able to use a lot less energy. The alternative is really to turn on the air conditioners within the data center. And our evaporative cooling design is a much more water-efficient approach. And so as we're thinking about how to manage water and energy together, being efficient about using water for cooling helps us manage both of those and minimize our environmental impact. And so we've been already thinking about water sustainability within AWS operations for years now. Before we build a new data center, before we go into a new region, we think carefully about whether it's responsible to use water for cooling in that region. We look at the availability of water and the risk around water, and we ask if it's the right decision for the community, for the business, and for our customers to be water cooled in that region. And in certain regions, like in Cape Town, South Africa, and in Hyderabad, India, we decide to do an air-cooled design instead. So we're really deliberate and careful about where we choose to use water for cooling and make sure it's the right decision for us as a business as well as the community. Then when we do use water for cooling, we have a really highly efficient design, this evaporative cooling design that I referred to before. Much of the year, we actually don't turn on the water. We use free air cooling, which just means we pull in air from the outside to cool the servers. And then on the hottest days, we use water to cool the data centers further. So in some of our regions, we're actually only turning on that water system about 5% of the time, which allows us to also decrease water use. But there's more that we can do, and that is why this week we announced a new sustainability commitment with AWS, which we call Water Positive. The goal is to return more water to communities than we use in our direct operations by 2030. We're going to meet this goal in a couple ways. We're both going to reduce our impact within our data centers, and we're also going to invest in projects within communities to increase water availability. Together, that's going to help us ensure that we're having a positive impact on water resources wherever we operate. So I'm going to walk you through each of the ways that we're going to meet the goal, and then I'm going to share a great video with you from the team that stands behind me every day helping to implement this goal. So the first way that we're working to meet the goal is through switching to sustainable water sources. A lot of us, when we turn on the faucet every day, we get clean drinking water coming out. And a lot of the data center industry uses that same clean drinking water to cool their data centers. But the truth is we can use lower quality for cooling. And so we're trying to change that as much wherever we can to use lower quality sources like recycled water for cooling. What is recycled water? It's basically treated sewage. It's perfectly safe to use within data center, but it's not used for a lot of other uses. You won't see that coming out of your tap within your house. So if we can leave the drinking water, the clean drinking water for other uses within the community by using recycled water, we're helping to make sure that we're expanding water access within the community. We would use recycled water everywhere if we could, but the truth is it's not available in all communities. Some communities have built the treatment and the distribution systems that you need to deliver the clean water, and others haven't. So where it's available, we're integrating it into our data centers for cooling, and where it's not, we're working with local water utilities to figure out how we can help co-invest in that system together to expand access to recycled water. The other sustainable water source that we're using is rainwater harvesting. We're capturing the rainwater that falls onto our roofs, and we're integrating it into our data centers for cooling. And that allows us to also use less water coming from the public water system. And what you see here is, going back to the recycled water, you can see the separate pipe labeled with purple, which signifies that's recycled water coming in, separate system from the domestic water, the clean drinking water, and this is actually from one of our data centers where we're using recycled water. The next strategy is around water efficiency. An important and really exciting part of the announcement that we made this week was, for the first time, we announced our water use efficiency metric within our data centers. And we're able to show that we only use 0.25 liters per kilowatt hour. That's kind of the standard measure of data center water efficiency. You take all of the water that you use globally and you divide it by all the energy that you use. And if you look across the industry, 0.25 liters per kilowatt hour is highly efficient. It compares to a standard measure that's more in the 1 to 2 liter per kilowatt hour range. And we've done that in a few different ways. One, as I mentioned before, we have that highly efficient evaporative cooling design. We also are using AWS services to track our water use in real time and notify us when we're using more water than we should. I'm going to touch on that again briefly at the end of the presentation. And then we're using treatment within our data centers to treat water and increase the number of times that we can cycle that water through our cooling units. All of that adds up to that industry-leading 0.25 liter per kilowatt hour metric, something we're really proud of and that we're going to continue to expand on as we implement this program. Third, we are reusing our cooling water. So as I mentioned, we cycle that cooling water through our system as many times as possible, but it gets to the point where we have to discharge it and bring in fresh water. But that water we discharge is still perfectly safe to use in other applications, like in irrigation. So where possible, we're providing that water directly to the community so that they can use it, like in our region in Eastern Oregon, where we're providing 96% of the cooling water that we discharge to farmers. You can see here we discharge it into an irrigation canal, it flows down to farmers, and they're using that in our Eastern Oregon region to irrigate corn, soybeans, and wheat. And to make sure that that project is successful and safe, we're also using AWS services to monitor that water quality in real time to ensure that the water we're providing to the farmers is high quality and always safe. And that helps us be sure, and the farmers be sure, that they're receiving safe and clean water. So those first three categories are really related to our data centers. Those are the ways that we're working to directly minimize our water impact within our footprint, within our four walls. The final part of our water sustainability program of the Water Positive goal is supporting projects within communities, projects we call water replenishment projects. They look different in different parts of the world depending on what the water challenge is in that region. So for example, in Cape Town, South Africa, you may remember headlines in 2018 and 2019 where they were approaching what they called day zero, when they were going to be forced to shut off the water taps because of scarcity. And so we've supported projects there with the Nature Conservancy to remove invasive species from that watershed. Those invasive species were soaking up water, and once they're removed, that water can instead flow down into the city's reservoirs and make more water available to the community. In other places, we are investing in projects to improve water quality where scarcity is less of an issue. And finally, we're also investing in projects to expand water access, like in India and Indonesia. And we're investing in these projects across our global footprint. I'll give you a couple examples of those replenishment projects in action. There are some projects, this is one of them, in fact, that we started this program a couple years ago. This is one of the first projects that we invested in. We partnered with a global nonprofit called water.org that's dedicated to expanding access to clean water. And we helped bring sanitation and clean water to 250,000 people in India and Indonesia with water.org. This is one example here. This woman pictured as one of the beneficiaries. Her name is Usha. Her and her family live in the Hyderabad area in India. And before this project, they did not have access to clean water or to sanitation in their home. They bought water from tanker trucks in the neighborhood, and they would use community toilets. They spent a lot of time and a lot of money accessing that clean water every day. We worked with water.org and local microfinance institutions to provide a very small loan that would allow her to bring water and sanitation into the house. Water.org's model is really interesting. They recognized that the key challenge, that there were many people who lived in areas where water could be available, but the key challenge was that they didn't have the upfront capital to connect their home to the pipe that ran right outside of their house. And so by working with local microfinance institutions, they can help provide that capital. And while they do pay that loan back over time, those loans are paid back at a 99% rate. And they also the families, like Usha's family, ends up spending a lot less money, even with that loan factored in, than they did previously on accessing water from trucks. It also improves their health and safety within the family and saves them a lot of time that they don't need to spend anymore going to locate water during the day. That's one of the types of scalable interventions that we're helping support to address the key challenge within that area where we're operating. We also, in that same area, Hyderabad area, worked with another nonprofit called Water Aid to implement groundwater recharge, rainwater harvesting, and piped water connections within the community, and reached an additional 40,000 people with clean water through those projects. Another example on the other side of the world is a project that we're implementing in the Thames River Basin outside of London. You may have heard the headlines just this past summer where London was experiencing the hottest summer on record and the driest summer in 50 years, which put a lot of strain on the water resources in the community. We've been working since this past year with a group called the Rivers Trust and a local partners of theirs, the Action for the River Kennet, to build 2 wetlands on a tributary of the Thames River. Those wetlands are receiving water from a local farm as well as runoff from a highway. They're treating that water naturally, allowing those pollutants to settle out over time, and then recharging the groundwater, which is really important because as the drought was impacting that area, local water agencies started pumping more groundwater. These wetlands are now recharging that groundwater, ensuring that they're a long-term sustainable source of supply for those communities. So you see right here one of the wetlands that we've been building. One of them's complete, the other one is nearly complete. And in the spring, we're going to have a big party where we all come together to plant those wetlands, and they will look less like a dirt pile and more like a beautiful ecosystem that is able to provide those water quality and quantity benefits. And then the next question for us is, once these projects are done, how do we scale that up? These projects are wonderful, but we want to think about how we can bring other partners in to support those same goals within the watershed and improve water quality and water quantity at the watershed scale. So that's a broad overview of how we're planning to meet the goal and some examples of what we've done already. Now, I'm going to stop talking on stage. You'll actually hear me a little bit in this video, unfortunately, as well. But more importantly, you're going to hear from teammates at AWS who are helping to implement these goals. And then I'll wrap up before handing over to Paul. Water connects everything we do in life. But too often, it's overlooked or taken for granted. In the next 10 years, over half the world's population is expected to be living in areas affected by water scarcity. And climate change is only making that worse. The good news is that there are many solutions out there that can help us address these water challenges. I'm Will Hughes, and I'm the Water Sustainability Lead at Amazon Web Services. AWS is committing to be water positive by 2030. That means we'll return more water to communities and the environment than we use in our operations. We'll meet the water positive goal in two different ways. We're working with nonprofit partners around the world to invest in projects that increase water availability in the communities where we operate. Second, we're working within our data centers to implement innovative solutions that help us improve water efficiency and reduce our water use.
We only use water for cooling when we absolutely need to. I'm Suresh Soundaraj, and I'm a principal mechanical engineer at AWS. My job here is to design the most efficient cooling systems for our data centers. During hotter months, we use an evaporative cooling system which pulls in outside air and forces it through water-soaked cooling pads. The water evaporates, reducing the air's temperature, and the cool air is then directly supplied into the server rooms. To fine-tune our cooling operation, we install sensors that track the weather parameters like temperature and humidity. As soon as the conditions drop to a safe operating range, the evaporative cooling system shuts off and cool air is directly supplied into the server rooms. We're continuously innovating and improving our cooling system so that it's the most sustainable and efficient option out there.
At our Oregon data centers, 96% of our spent cooling water is used for irrigating crops like corn, wheat, and soybeans. I'm Kelly Galway, and I'm a Water Resources Data Manager at AWS. To make sure the water is safe enough for irrigation, we installed sensors that monitor water quality. The sensors continuously collect data, and AWS IoT gateways transmit the data to the cloud for analysis and automated alarming. If there are any water quality issues, we're instantly alerted. We've leveraged the power of the AWS cloud, offering a secure solution to collect data and scale the program very easily going forward.
Returning water back to the environment is a huge part of us becoming water positive. I'm Claire Biddle, and I'm a Water Resource Manager at AWS. In the United Kingdom, we're working with the charity The Rivers Trust and local trust Action for the River Kennet to create 2 wetlands on the tributary of the River Thames. This is one of London's main sources of drinkable water, but drought and pollution are threatening the region's long-term water security. The plants within the wetlands slow the water flow, which remove nutrients and sediments. The wetlands will also help recharge local groundwater, which makes the area more resilient to drought. AWS is already investing in nature-based solutions around the world. Each one of these projects is delivering improved water quality and availability for the surrounding communities.
I'm hopeful because we're seeing more innovation in the water sector than we've ever seen before. We're seeing new technologies that can fundamentally change how we address these water challenges, and AWS is excited to be part of driving those innovations forward. With each change, we're making a more sustainable future for our company and our customers. But most importantly, we're making a better future for our planet. All right, thanks to the team that is actually behind me doing all this great work. To sum up, here are some of the key stats of what we've achieved so far. 20 of our data centers are using recycled water. We've already talked about the water efficiency and how that's an industry-leading figure. We're hoping to lead the way in showing how the data center industry can become more efficient in water use. We've also, with those replenishment projects that we've discussed and some others that are underway now, we're expecting to return 2.4 billion liters of water back to communities. So the main takeaway here is, while there's a lot more to go, this is not just a starting point for us. We're several years into this already. We're really proud of the progress we've made to date and excited about what's to come. Before I hand over to Paul, I'm going to talk a couple ways about how we're using AWS services to meet the goal. So as I mentioned before, we're using AWS services to track our water use in real time. You can see here an actual printout of the system that we use from one of our data centers in Oregon. The bars show the actual water use on a daily basis. The line shows what we expect the water use to be. So we're constantly mapping the actuals against the expected to determine if we're using more water than we should. Here you're seeing we're doing a pretty good job. We're using less than we expect the data center to be using. But if those bars creep above the line, it would cut a ticket to the AWS Water team, as well as to the data center operators, to let them know that we're using more than expected. And then we can go investigate the cause of that. It may be that a valve is stuck open. It may be that a change was made to the operating system within the data centers. We can go figure that out and eliminate water waste very quickly. And we're using AWS services like IoT Core, Lambda, S3, TimeStream, and others to implement this. The other thing that we're doing is we're using partners we're working with partners that have built services on AWS to implement the Water Positive program. This one in particular is a close partner of ours, WaterPlan. They built an industry-leading solution that helps us assess water risk and determine what the key projects are within a watershed that we should be investing in. They monitor things with updated data like water quantity risk, water quality risk, water access, and that allows us to use data to determine the projects that the replenishment projects that we should be investing in. And they were built on AWS using services like DynamoDB, AWS Comprehend, CloudFront, and S3. And using those services, they've been able to scale an industry-leading solution very quickly. They launched in 2019, and they're already at the forefront working with us and others to help implement water stewardship programs. So with all that, again, we're excited about the progress that we've made. We're excited about how we're integrating AWS services into meeting this goal, and we're excited about what is yet to come. And with that, I'm going to hand it off to Paul to talk about how we're scaling our renewable energy efforts.
Thanks, Will. Super exciting progress. Really good. Congratulations to you and the team. Great day one. Great start. In 2019, Amazon co-founded the Climate Pledge with Global Optimism to build a cross-sector community of companies, organizations, individuals, and partners working together to address the climate crisis and solve the challenges of decarbonizing our economy. The Climate Pledge is a commitment to reach net zero emissions by 2040, 10 years ahead of the Paris Agreement. Scientists tell us that we have a limited window to make unprecedented headway in order to limit global warming to 1.5 degrees Celsius by 2050. No one company or organization can do this on its own, and everyone must do their part. To drive collective cross-sector action on the climate crisis, Amazon co-founded the Climate Pledge based on the conviction that global businesses are responsible, accountable, and able to act on the climate crisis. As Will mentioned, our public stated commitments to the Climate Pledge are to achieve net zero carbon by 2040, and to power our operations with 100% renewable energy, which we initially committed to reach by 2030, but we're now on a path to meet that target by 2025. Today, Amazon has over 380 renewable energy projects. As the largest corporate purchaser of renewable energy globally, Amazon now has renewable energy projects across 21 countries, including 160 wind and solar farms, and 220 rooftop solar projects, representing 19 gigawatts of renewable energy capacity. To put that in context, the total renewable energy projects established by Amazon will generate over 50,000 gigawatt hours of clean energy, or enough to power 4.8 million US homes each year. By the end of 2021, Amazon reached 85% renewable energy across our business. In addition to growing Amazon's procurement of renewable power, We want to ensure that we're maximizing the clean energy generated by these assets, much like what Will was talking about with what we're doing with water. To do this, we've developed cloud-based software to manage and optimize our portfolio of solar, wind, and battery capacity across the globe. This enables us to accelerate adoption of 100% renewable clean energy across our businesses. Let's take a deeper look at some of the challenges we face in maximizing generation from renewables and why this cloud software innovation is critical to helping us meet our goals. Unlike traditional energy sources, renewable sources have variable production. Investments in renewable assets are therefore focused in locations that offer the best chance of higher and more consistent output. Looking at the US, for example, there are areas with less cloud cover and fewer pollutants in the atmosphere. For wind power, there's places that have historically higher and more consistent, stronger winds. In addition to weather, we need to consider seasonality. For example, cities such as Denver, Colorado receive nearly 3 times more energy in June than they do in December. So while putting renewable generation assets in these locations gives us a higher likelihood of consistent and high production, it's no guarantee, and we still need to account for weather and seasonal variation to maximize output. In addition to variable energy production, we need to move that power from where it's generated to where it's consumed. This relies on the overall power grid to have reliable and available capacity to deliver power in the face of increasing demand from all consumers, not just Amazon. As Amazon's energy portfolio grows, we're increasingly exposed to fluctuations in energy markets, energy market prices, and congestion on the power grid. One of the challenges mentioned previously is the effect of weather on renewable generation. But it's more than the day-to-day effects of weather patterns we need to consider. We're increasingly experiencing extreme weather events and long-term climate patterns such as the El Niño and La Niña events. Natural disasters such as the ice storms in Texas, wildfires in California, not only strain the capacity and capabilities of the grid to serve power to its customers, but increase variability in production of those renewable assets, from pollutants in the atmosphere impacting performance to vastly different wind patterns. Understanding these macro changes and their effect on renewable generation and sources of energy is critical to being able to maximize production today and in the future. So to do this, we've developed REO, Renewable Energy Optimization, a machine learning-based solution to manage and optimize our portfolio of solar, wind, and battery capacity across the globe. REO is a utility-scale solution built on AWS that automates data acquisition and analysis to maximize delivery of clean energy to where our operations need it. REO collects and transforms real-time IoT data from renewable energy assets, the grid, electricity markets, and external feeds such as weather data into a structured data lake. We then apply machine learning, ML models, and optimization algorithms trained on millions of data points to improve delivery of clean energy and battery storage on the grid. Our forecasting models determine renewable generation, annual production shortfall, electricity prices, and grid conditions. We perform dispatch optimization for energy delivery from renewable and battery storage systems. Our ML models are used to increase generation output by maximizing downtime of assets in need of maintenance. And configurable APIs enable embedding REO's optimization engine directly into energy asset operations applications. Let's dive a little deeper into how we've built this on the AWS cloud. It all starts with data. Millions of data points from thousands of devices at the edge, including SCADA systems, third-party protocol converters, data historians, and web APIs. We use 2 main methods to acquire data. First, REO uses AWS IoT Greengrass to stream data. Greengrass supports multiple native connections to transfer high-volume, high-resolution data to AWS. We then route that data to AWS Kinesis using the Greengrass Stream Manager for its batching and exporting functions. With this solution, REO can reliably stream thousands of data points from a single renewable asset to the cloud at scale and at low cost. Alternatively, data from some sources may come through an API rather than streamed directly. For these, an AWS Lambda function is scheduled to read the data from the API and send the data on to Amazon Kinesis. In both cases, another Lambda function is initiated by Kinesis. This processes the raw data, maps and transforms the data, and then sends it to a target storage system. In our case, it's either AWS IoT Sitewise or Amazon TimeStream. We chose Sitewise to serve as the historian to save data in an organized pattern. Sitewise is a fully managed serverless architecture that eliminates operations and maintenance for the REO team. It enables us to have a standard hierarchical asset model that efficiently and flexibly organizes renewable assets. And we can quickly compute common industrial performance metrics across our data sets. We chose TimeStream to store all of the raw data. TimeStream is a fast, scalable, and serverless time series database. It gives us high performance at a low cost. And we can easily query and aggregate data or connect to Grafana for real-time dashboards. In addition to Sitewise and TimeStream, we send our data to a data lake built on top of S3 with 3 different levels of data purity. This enables ad hoc queries and visualization using services such as QuickSight, Redshift, and Athena, and ML model development using services such as Forecast and SageMaker. Together, we use these to explore new optimization problems and expand the REO solution. Using these AWS services, REO can monitor the delivery of clean energy onto the grid, helping us address challenges in optimizing the largest corporate fleet of renewables across the world. We've developed machine learning models that help us make better predictions of production output, optimization algorithms to help dispatch resources on the grid, and operational dashboards that provide insights based on real-time data. Dashboards such as this one enable operators to visualize our grid portfolio of renewable generation assets in near real time. They're able to easily see performance, environmental, and operational telemetry in one place and drill down into areas of interest. Here we see a heat map showing turbine performance for a wind farm. Each row represents power output from a single turbine over time, with higher output indicated by darker red and lower output shown in blue. From this, we can quickly identify underperforming resources. For example, the solid purple line here indicates a turbine that's offline for the entire day, but perhaps it's under maintenance or some other operational event. More interestingly, we see 2 turbines that were offline at the beginning of the day when power production across the farm was at its highest. If this was scheduled maintenance, perhaps we should move maintenance later in the day to avoid taking turbines offline when they may be most productive. Smart plant operators, potentially located thousands of miles away from this farm, can look at these heat maps and quickly get an understanding on operational performance. We can drill further into this data and look at individual assets. In this case, one of the turbines. Here we see power output graphed against wind speed. In general, we see a correlation between these 2 graphs. When wind speed changes, we see a corresponding power output change. But if you look closer, there's 2 features here which stand out. First, there's this period of time where wind speed continues to increase, but we don't see a corresponding increase in power output. Now, a skilled operator will look at this and not be concerned, because what's happening is, as the turbine is performing optimally, because as it hits a steady state of production, it hits a steady state of production even as wind speed increases, and this is an optimal situation for the turbine, so we'd expect this behavior. Second, we see a power output dropping to 0 as wind speed drops. Again, this is sort of expected, since when the wind speed drops below a certain threshold, turbines are unable to produce any power. Essentially, there's just not enough wind to turn the blades. Smart plant operators can look across all these dashboards and identify such insights, but with over 380 renewable assets that operate 24 hours a day and 7 days a week, it would take tens or hundreds of people working around the clock to draw out these insights. So by using machine learning, we can automate these insights from the data, detect anomalies, and automatically notify operators so they can focus on the events that matter and just the events that matter. AWS developed REO to maximize the potential of our global portfolio of renewable generation projects, helping us deliver on our commitment with the Climate Pledge to power our operations with 100% renewable energy. We'll continue to build out REO to help achieve this commitment, as well as sharing our learnings, tools, and innovations to help our customers deliver on their sustainability goals. At Amazon, we're committed to and invested in sustainability because it's a win all round. It's good for the planet, for business, for our customers, and for our communities. To learn more about what we're doing to drive sustainability across Amazon and beyond, you can attend some of these sessions going on here at reInvent, either in person this week or on the AWS channels later. Or for more information, you can visit reinvent.awsevents.com/community/sustainability. Thanks for your time, and I hope you have a good evening.